Oh, that's the other thing, Charlie. You're aware we record and put it up on the website. Yeah. So a very good morning to you all. Thank you for joining us on this Friday. Super subject today. We're going to be talking about assessing carbon in timber products and buildings, which obviously is important to me with my daytime job, so to speak, with the STA, but also in terms of best practice with CE. So we're expecting a good house today. We've opened up slightly early to let everybody in so that we can start as soon as we can. But while you're waiting, ladies and gentlemen, you might like to go to slido.com. Those of you that are regular viewers will know that we use slido.com for everything for these Friday webinars. You'll see the code for today is hashtag LM101221, which you won't be surprised to know is today's date. So go there, and we're going to have a poll to get us underway. I hope the poll is already up, a bit of a survey. So while you're waiting for us to start, ladies and gentlemen, please do go to slido.com and answer that poll. That would be super. And I've just had a note from David Lambert to ask if we could put the details in the chat. Abraham, can you arrange that, please? Can you put the Slido details in chat? They are on the screen, but we'll certainly do that for you, David. Yeah. We're just going to give folks, it's only just turned midday, so I know a lot of people sort of skate in from one Teams meeting to another or one Zoom meeting to another, so just bear with us another minute or so whilst we welcome more people into the room, and then we'll make a start. So just bear with us, but please do go on to that slido.com link now and tap in hashtag LM101221 and get underway with the survey, which I'm going to be going through the answers with Charlie at the end of his presentation. So that's good. Right, I think I'm going to make a start in view of the fact that I've kindly got here on time. So a very warm welcome. Good afternoon to you all. This is our penultimate webinar for 2021. Hard to believe that we actually started these Friday sessions nearly 2 years ago. It was back in March last year at the start of lockdown that we kicked in with these, and obviously initially working on COVID-19 topics, but now we've broadened it. And we've been joined, initially it was run by the STA, Constructing Excellence in the Midlands and the Southwest. But we've been joined now, if you look on the screen, by all the other CE regions and also by the CIOB. So it's quite a conglomerate of organizations now working together to bring you these Friday sessions, which I know you're enjoying and I know you find valuable. So for those that have just come in, once again, we're using slido.com today for both the questions that we're going to ask Charlie later, but also for a poll, a survey that we want you to fill out. So if you could go to that now, slido.com with hashtag LM101221, fill in that poll if you would. And then as the presentation goes forward, please, if you've got any questions for Charlie, please do pop them in that slido.com and we'll ask them later on. Now, today's topic is very relevant to me, not only with my CE hat on, but particularly with my STA hat on. It's all about assessing carbon in timber products and buildings. Now, a couple of weeks ago, 3 weeks ago, whenever it was, I was up at COP26. And there was no doubt in my mind that the two big issues that came out on Built Environment Day, which was the penultimate day of the COP26, the two big issues, one was retrofit and the second was embodied carbon. And today is really going to be dealing about how we can assess embodied carbon in buildings. So it's going to be critical going forward. So Charlie, I'm delighted that you've been able to give us some time in your busy diary, because I'm sure we're all going to find what you have to say in your presentation very valuable, very interesting, and I'm sure there will be some questions that flood out of what you have to say. But I think probably for now it's best if I mute myself, turn my camera off, and hand over to you, and then we'll come back later with the Q&A. Thanks,
Great.
Charlie.
Thanks, Andrew. Appreciate that. Thanks very much. Okay, I'll just start sharing my screen. Just 2 seconds here then. Just get this, make sure this all works. Okay, hopefully you can all see my screen now.
We can't yet.
Not yet. It's probably still thinking about it. Sometimes it takes a bit of time.
It says that you've started to screen share, but it hasn't popped through yet.
Hasn't popped up yet. No worries. Let me know when it should come up any second now. There we go. Should be there now. Is that right?
Yeah, we're all systems go, Charlie. Over
Great
to you.
Stuff. Brilliant stuff. Thanks very much. Right then. So, just a bit about today. So a bit about myself. So my name's Charlie Law. As Andrew says, I'm a sustainability director of Timber Development UK. That's one of the many hats I wear, similar to Andrew. Got a number of hats. For those of you who don't know, Timber Development UK is the new organisation formed by the merger of the Timber Trade Federation and the Timber Research and Development Association. They merged back in March. We're still in effect trading under the 2 separate names at the moment, but they will start to come together over 2022. A bit more about myself. I've actually worked in the construction sector for well over 30 years now, 12 of which was spent as head of environmental management at BAM Construct UK. Well, I spent a lot of my time looking at waste responsible sourcing, timber, circular economy, and a bit on carbon, not a hell of a lot. We had a very good carbon person there that done most of the legwork on that, but used to keep my eye on that. Obviously, I also run my own sustainability consultancy, where I've worked for a number of organisations, including Kier, Lendlease, HS2, and others, on circular economy initiatives that incorporate low carbon, responsible sourcing, and waste reduction is the key bit. So today's presentation, I say it's based on a paper I'll show you in a second, but a lot of this was put together by a lady called Jane Anderson, who some of you may know, who is a world-renowned expert on carbon and life cycle assessment. So the technical paper that we drew up at Timber Development UK was drawn up by her, and these slides are based on that technical paper, basically. So Jane, if you don't know, is an expert on the UK SEN TC 350 Working Group 3, which developed the EN standards around this, so things like EN 15804, which is the European standard for construction products, and also on the ISO TC 59 Working Group, which is developing the ISO standard. And she recently took over the chairmanship of the of B558, which is the UK Mirror Committee for Sustainable Construction Standards. So, like I say, very experienced person that's put this this information together for us, and I'm going to try and explain that to you today. So, as David said, number of drivers around net zero carbon that are coming out of the COP26 and the UK government. Obviously, we set the target back in 2050 for a net zero by 2050, and that was set in June 2019, which everyone thought, yep, that's really good. But then earlier this year, they actually came out with this new target, interim target of 78% reduction by 2035 compared with 1990 levels. So a massive reduction early on, which is really good, because a lot of the stuff that was talked about on COP26 was around how we was maybe leaving it too late for some of those key reductions. And so the UK government has actually put its head above the parapet there and said, yep, we're going to actually have a 78% reduction by 2035, which is a really good target. And we hope a lot of the other nations start to follow that. There's obviously been a number of targets around the not just around in the UK, but around the world, including people like the Construction Leadership Council with their Net Zero, Construct Zero Challenge, World and UK Green Building Councils, and many manufacturers and merchants. I know that we're talking to are setting their own targets around net zero and how quickly they might be able to achieve these. So just to give you an idea of, we're going to be talking really about embodied carbon today. And just to give you an idea, at the moment, probably it's estimated that buildings built today, probably around 25 to 30% of their carbon emissions will be embodied. So that's in the materials that building or structure is made out of. The rest are in those operational emissions throughout the life. But obviously, we're seeing a lot more energy efficiency systems coming in to buildings. Heat pumps we're talking about being fitted from all new buildings by 2025. Obviously, fabric upgrades to existing buildings. So what's going to happen? That overall operational energy level is going to fall significantly, which means although it's going to be a smaller number, the embodied energy in the building is going to be a much higher proportion of the building's life cycle emissions. So that's why that's so important that we have to tackle that. So this is the paper that I mentioned. It's quite a title on it, Assessing the Carbon Related Impacts and Benefits of Timber in Construction Products and Buildings. So that's the technical paper. It's available to download free of charge from the Timber Trade Federation website at the moment. And basically splitting it 3 parts really, and that's what we're going to cover in today's presentation. It covers the carbon related impacts of timber generally, how they're assessed, what they are. It talks about timber environmental product declarations, how they're put together, the various stages of those. And then it talks about how we take those environmental product declarations and incorporate that into a whole life carbon assessment at a building level. So that's the sort of 3 areas that we're going to try and focus on today. So first of all, if we sort of look at how the forest goes together, really, you know, what is the carbon story? And these are quite little animations that were done by Wood for Good a number of years ago. I'll leave the sound off, but I'll talk through it, which is basically the hectare story, which talks about the life cycle of a forest. So we've got obviously a newly planted forest here. How does that take up the carbon in the atmosphere? What is the process of trees growing is the first thing that we're going to look at. So this is a typical Sitka spruce plantation that probably in the UK, and that, you know, a hectare of that plantation will absorb around 483 tons of carbon over its life cycle. So in year 1, obviously, not so much is happening. Year going, you know, the carbon will be starting to take up, but as it starts to grow, that carbon's been sucked up. You'll then have thinnings, probably around 15 to 20 years, where they start to take timber out for different products, usually panel products, OSBs, that sort of stuff. Later on, maybe 25, 30 years, you'll start to see some sawn timber coming out of that, maybe some fencing panels, that sort of thing coming out of that, fencing panels, posts. And then, you know, ever actually getting shorter now, talking to the Forestry Commission, actually up to 35 years, they might be clear felling, but generally around 40 years, they're then clear fell that stand. And that's generally your sawn timber that you'll see in the structural timber applications that we'll use in construction. But obviously, once they've felled those trees, they're going to be planted a lot more in that same area of land generally. So you can see there that, you know, it's, you know, timber is an absolutely really sustainable project. Replanting, regrowing that timber over its life cycle, over that 40-year cycle. So that's, you know, as it says, using timber is good for the environment. It is in our eyes. But just to give you some more facts and figures behind that, really, we need to understand the carbon balance. And people sort of say to me, well, you know, you chop a tree down, that carbon's been lost. It's not going to be sucking carbon up anymore. But, you know, and then you lose a certain amount in that first few years while it's starting to regrow. It's not sucking up as much carbon as it could be. And yep, absolutely, that's true on that hectare basis. But what you've got to do is actually look at this at a European level or UK level. Now, this is the European level now. That then starts to even out all of those little sawtooth graphs that you might see where the carbon drops off. Actually, the carbon sink in Europe is growing. It's currently sitting, there's around 227 million hectares of forest in Europe. That includes the UK, by the way. When I'm talking about Europe, I'm not talking EU now, I'm talking Europe. That includes the UK. And that covers around 35% of the land area on average. And that is growing on average by about 0.2% per annum at the moment. Now, it's estimated that the carbon stock in the tree biomass and the soil and everything else in there is around 135 billion tonnes of CO2 that's being stored in there. And the annual uptake is around 570 million tonnes. That's taken into account removals through harvesting and everything else. So, you know, that's taken up a lot of carbon over time. So when you look at this, you'll see there's a lot of aspects of that carbon storage. So you've got the dark green there is the tree biomass, and that's just a small proportion of this carbon that's being stored. You've actually got, you know, above ground, the below ground biomass, so things like the roots and everything else, which is the sort of light brown line there. You've got dead wood and litter in the sitting on the ground. You've also got the soil that's storing a load of carbon, and you must make sure that we replant those trees. Otherwise, that soil carbon can be lost. If we look at that from the UK perspective, very similar story, but you'll see that biomass that's stored in the above ground is much lower. There's not as much tree, not as much tree cover in the UK. We've only got about 13% here, so that 3.2 million hectares. But you still got quite a bit held in the soils and everything else. This is through Forestry Commission figures and stuff like that. But the key thing to note here is that you've got that light green line on the top, which is the harvested wood products. You'll see that makes up quite a significant proportion of the stored biomass in the UK. So that's the stuff that's stored in our buildings, stored in our furniture and stuff like that. It's quite a significant proportion that's being stored there. And that's, you see it's probably about sort of 50% of the tree biomass. It's quite a significant proportion, and we're still taking up quite a bit. That's looking at the UK, it's storing that's about 4.2 billion tons, and it's taking up around 20 million tons a year in the storage. So quite significant amounts of carbon being sucked out of the atmosphere by our trees, and that's one of the reasons why we do need to make sure that we try and plant a lot more trees in the UK. We need to get that tree cover up from that 13% to, I'm not saying we're going to get it up to the European levels of 35, but we do need to be getting it maybe near 20%. And that's going to allow us to store a lot more carbon. So obviously we've got that CO2 being sucked out the atmosphere into those trees, and those trees are obviously then perspirating, sending carbon out. Sending that CO2 back out, oxygen back out into the atmosphere, and the carbon itself is actually stored in the wood then. And looking at an EPD, this is a typical EPD for a Swedish sawn timber. So this is from Stora Enso, this particular one. They say that their spruce stores 733 kilograms of CO2 per cubic meter of timber. That timber is kept in the system. That CO2 is stored in that timber for as long as that timber is in use. So if it goes into a timber house, it's stored in there for 100 years, so in a joist. If it comes out of that house and then gets recycled into a panel board or something like that, that carbon is still being stored within that board product. So it's not released until it actually gets disposed of, or in most cases actually it's probably going to be burnt. And then obviously you then take some of that CO2 out of the atmosphere, mixing it with the carbon, and that's your CO2 being emitted into the atmosphere again, which, in the cycle is going to be sucked up by those trees again. So it is, a virtuous circle there, that the CO2 that we do emit from that burning process does get sucked back up by those trees. However, we're thinking now that actually when we start burning biomass for energy production in the future, are we actually going to be emitting that CO2 into the atmosphere in 20, 30, 40 years time when that timber comes out of the building? I'm not so sure. I think by that time there will be some form of other mechanical carbon capture and storage that's taken out of the atmosphere. So, that carbon doesn't actually get emitted into the atmosphere going forward. But that's a question for the future. But at the moment, we have to account for it as being emitted at the end of life. That's the one problem we've got. So that's the sequestration cycle. Now, the other question we get asked a lot of the time is, when should we take account of that carbon in the structure? And this has been a bit of a discussion we've had on the Timber Development UK Carbon Group. Do we look at it as a backwards accounting or forwards accounting process? There's a few people saying, we should be making a forwards accounting. Just to give you a few issues with that, this is how the backwards approach. This is the way that most people look at it. You've got that tree starting off in year zero, -50. We're saying -50. That's when the tree started to grow, and we harvest it at 50 years. And that harvesting process and production process, there's obviously a small amount of carbon that's required, energy and everything else. That means that net figure comes from now 733, for example, that we use for the Stora Enso timber, maybe drops up to more like just under sort of 6.5, 650, something like that. Now that carbon, like we say, in that process, is then stored in the timber for the length of the project. Excuse me, for the length of that building. Sorry, it doesn't emit, it doesn't release that carbon unless, like we say, you burn it or take it down and dispose of it in landfill. So that's the approach that most people think we should be taking. There is obviously a crowd out there that says, well, actually, we shouldn't take account of that carbon. We should, we should take account of the carbon over some of the life of the building. Now, the problem with that is that you've got a gap. There's a missing piece of carbon there that isn't in the atmosphere anywhere. It's it's missing, because it has been sucked out by that tree and that timber that you're using. It doesn't, it doesn't suddenly reappear later on. So we've got this missing carbon that's not in the accounting period. And just to reiterate, you must make sure, if you're going to take account of this carbon, you must make sure that your timber is from, a sustainable source. Certified in most cases is the requirement, and in the UK that is generally the case anyway. If you're working elsewhere, that might be something you need to check. But in the UK, generally, all the timber that comes in here for EUTR previously and now UKTR must make sure that it meets those requirements anyway. So we've got that missing carbon. So that's why as far as we're concerned, we haven't taken it account that way. We're taking that backwards approach. And that's the way the standards actually use it. They actually take account of that carbon at year zero. It comes down and they take account of that figure here. So we've got this dotted bold line, which is the EN standard, says, right, you take account of the carbon. If you are doing a whole life assessment, you can take account of the sequestration. If you are doing a whole life carbon assessment, if you're not, you can't. You just have to have a line up here. But they do say the one thing with the EN standards, you have to take a nominal period, which they say at the moment, most people are taking 60 years, where that carbon is then released back into the atmosphere. And there is a bit of an issue with us in the timber industry. We're not necessarily sure that a building will be demolished after 60 years. And even if it is, it's obviously going to get reused. So there are a few questions there, but they basically say you have to hand that carbon back at the end of life. And we'll go through that in a bit more detail as we go through the course here. But you still end up with a very low carbon output here. So just on the standards, we mentioned them a couple of times. What are the two main standards? Well, there's two main ones that we work to in construction. So there's BSEN 15804. So that's the one for sustainability of construction products, construction works, environmental product declaration. So that's the core rules, what they call the category rules for construction products. So that's the actual product itself, whether that's a piece of timber, a CLT panel, an I-beam, whatever it might be. That's for that EPD. You then have BSEN 15978, which is the Sustainability of Construction Works Assessment of Environmental Performance of Buildings. So this is the actual building level assessment then. Okay, so there's the two levels. So you've got the product assessment is 15804 and the building level at 15978. Now, to accompany that, the RICS have also come out with what they call their professional statement on the whole life carbon assessment for the built environment. That was released in 2017. It's currently being updated at the moment by Simon Sturgis and her team, including Jane Anderson, who wrote our paper that we mentioned. So that team is actually working on an update to that at the moment, but that sort of tries to clarify some of the rules within 15978. Now, one of the key bits within the assessment of 978 is that they do require you to do a cradle to cradle assessment, so an end of life assessment. So you've got to make sure you include that end of life process, preferably module D as well, which is the benefits of that reuse in the next system, which doesn't form part of the calculation, but just gets put in as a number, this module D benefit. So you have to do a certain number of cradle to cradle assessments. For example, in the LCA, life cycle assessment for an environmental product declaration, need to make sure that you include a minimum of A1 to 3, which is the emissions up to the product and the factory gates in effect, and then C1 to 4, which is the end of life, and then that bit on module D around end of life. So that's the minimum you need to do as part of the new standard, which is the plus A2 version of 15804, which came out in 2019. So that's the two standards we work to. So both of them require whole life cycle assessment. Now, the issue is that 15978 does say you must do a whole life assessment, but a lot of professional bodies, so whether it's an architects or engineers, may not have all the information. So they may only do what they call an upfront assessment. I'm going to explain what an upfront assessment is in a second. And that's where the RICS professional statement comes in. It sort of gives you some rules about what you should include in if you're only doing an upfront assessment, because the standard itself, in effect, requires you to do a whole life assessment. So the standard, the RICS professional statement gives you a few options there. So just to look at the whole life assessment, what does it include? What do we need to include in that process? So there's a number of areas there. So starting off with A, so A1 to 3 is that raw material extraction, the transporting of that raw material to its production facility, and that manufacturing that into a product. So whether that's a piece of 6x2 sawn timber or an engineered product such as CLT, all of that, whatever the process is, that would be included in A1 to 3. The sequestration, if there is, if you're allowed to use that sequestration, you're doing a whole life assessment, that would be taken in A1. So that minus figure, 733 kilograms of CO2 that we mentioned, which is what's sequestered by that piece of Sitka spruce from Sweden, that would be put in as a minus figure against that raw material extraction figure. So A1, in most cases, near enough in all cases, would end up as a minus figure in the assessment. Okay, because you've got a small production figure that might be 20 or 30 kilograms per cubic meter, you then minus the 733, you're going to end up with a minus figure. Then all the other figures are going to be a plus. So A2 and A3 will be a plus figure. We'll give you some examples in a second of what these might look like. You then have A4 and 5, which is the construction stage. So that's taking the product from that manufacturing facility to the construction site. Now that could be quite a process. Some timber materials, if you've got CLT, that could be traveling quite a distance. A lot of CLT, majority comes from Austria, for example. So you're having to either transport that by lorry across land or put it on a boat and bring it over. That does have a certain amount of carbon emissions, and although generally low compared with a lot of other materials, that transport can be quite significant in the environmental product declaration. For example, it could be up to about 50 kilograms, in that A4 and 5 stage, and 40 to 70% of that could be that transport emission. So it could be quite significant. You've then got stage B, which is the in-use stage, so B1 to 5. So B1 to 5 is the embodied carbon bit. So things like energy in use, which timber doesn't have, so that's generally zero. But if you've got maintenance, repair, refurbishment, replacement, if you're having to replace certain elements of the building over its life cycle, that's where these would be included. So that would be, like I say, the A1 to 5 emissions would be, and the transport and would be included in that, in effect, that refurbishment stage, that would be included in B. You'd have to allow that if you had to replace certain elements over that life cycle of the building. So, for example, if the windows are only designed to last 30 years, you'd have to include a replacement cycle in there if you allow for a 60-year life cycle. Okay, so that's where we need to make sure that we look at longevity, circular economy initiatives, etc., to try and make sure that we keep those emissions as low as possible. The next, so that's just to explain that they are, that A1 to 5 and B1 to 5 are all embodied emissions, but the A1 to 5 emissions are also sometimes termed upfront carbon. So if you ever hear that term upfront, that's referring to that A1 to 5. In effect, all the emissions up to the handover of the building is in effect where you're getting to there. We then have some operational carbon, which we don't need to worry about with timber, because it's not an energy, it's not making energy, it's not lighting up, it's not doing anything. So there aren't any B7 and B6 emissions with timber anyway. So we then need to look at our end of life, which is C. So C1 to 4 is the deconstruction, transport of the waste material off site, any waste processing that's required, and then disposal. And we'll talk a bit more about what they may include, but disposal is, you're really talking about sort of in landfill in that situation. Waste processing can include some of your energy recovery and sort of transferring it into say panel boards or something like that. So that would be your waste processing bit. So anything that needs to be done to get that material to a point where it can be used for something else, whether it's biomass, whether it's panel boards, whatever it might be. And then we have this, let's say that's embodied carbon emissions as well. And then we have this, like say, this D section, which is beyond the building life cycle, which I'll go into a bit more detail later on, but it's basically the benefits of reusing that product from something else. So just to give you some examples here of some of the stuff that might be done. So A1 to 3, your raw material extraction might be 11 to 12 kilograms of carbon. So that's your harvester taking the tree out and cutting it down. That is process, and anything obviously management of the forest as well. So managing the forest through that 40 years would be included in that A1 emission. But you've then got that sequestered carbon which comes out. So you've got that minus figure of that 733 that comes out of that. You've then got the transport from the forest into the factory, which can be quite small. Here it's quite a significant one, this particular example, but that could be quite small because there's a lot of factories, especially for CLT and things like that, very close to the forest. And then you've got your manufacturing emissions. So this is things like kiln drying, the electricity used for the saws and stuff like that. And again, the key thing there is to try and see if we can use some of that waste material from the processing of the timber. We're going to get sawdust, we're going to get offcuts, using those for maybe biomass and CHP plants, so you can actually generate your own energy and heat to dry in those kilns. And a good example of that is the picture that we've got there. That is a factory, that's VHAG's factory in Austria. And that's that generates 38 gigawatts of renewable energy per annum from its biomass conversion, around 10,000 tons of the sawdust and offcuts. So that's enough energy supply the plant's electricity and heating needs, including its kiln drying, with the excess power sold off to the grid. And that's getting to be fairly common now for a lot of the larger timber suppliers. So that keeps that embodied A3 emission in particular very low, which is really good. And it will get lower over time as well. That's going to happen. There's a lot more companies starting to look at that process. We've then got our on-site emissions, and the good thing about again, these are relatively low. You're looking at a total of probably around 50 kilograms of CO2 per cubic meter, which is relatively low on site. And one of the key reasons for that is that although the transport might be transporting a lot of distance, the weight that you're transporting is quite low, so that does offset some of it. And also, when you do get to site, you look at something like CLT timber frame, the panels that you're lifting up into place are quite light as well. So you don't need a very large crane that's drawing lots of energy from the grid, or needs an additional generator because there's not enough power coming out the road. You can use a slightly smaller plant, which does have real spin-off benefits when you start looking at your carbon emissions, because then you can use that grid supply, and that grid supply is ever growing. As soon as you've got to put a generator in to run that crane, your emissions are going to start going up on site. So let's say can be quite small. Let's say the transport is a significant bit, like I say, can be up to 70% of the emissions of A4 and 5, but the on-site emissions again are generally low. We've then got that in-use stage, and like I said, we've got the maintenance, the repair, refurbishment, replacement of products. So this is where we really need to look at how we can make those products more durable, and that's through maybe good design. Making sure we haven't got issues where water is sitting in external components. It comes down to choice of materials, making sure we use durable timber species. So if we've got cladding on the outside of the building, maybe let's spend a bit extra. Let's not use a softwood cladding that may need to be replaced after 25 years. Let's maybe go with a hardwood, durable hardwood species, so a cedar or an oak or a sweet chestnut, or even some of these new modified timbers that you can see now. And this is an example here. This is a product called Brimstone, which actually is a modified hardwood. It's heat treated, made from ash, so things like ash dieback and stuff. This is a use for that product because it heat treats it. Can also be used on sycamore and popular, they're using it for as well. It heat treats it, and it changes the properties within that timber so that it lasts for much longer. So things like that, if we can make those timber last longer, windows or coir is another example for windows and stuff like that. You can then make that timber last the life cycle of the building, and you won't have any maintenance costs. You then got to include that end of life, and this is the key bit that does cause a bit of an issue for the timber industry, because we ended up having to put that CO2 back into into the mix. That sequestered CO2 that we took out at the beginning, we have to add it back in here. Now, just to give you some numbers around what happens to timber at the end of life at the moment, this is as of now, around 69% of that waste timber goes into biomass energy production. Some are, biomass is better than others, but overall it's about 69%. You've got about 20% going into recycled panel boards, and around 10% going into animal beddings and other surface dressings, things like, paving paths, that sort of thing. And less than 1% actually goes to landfill. And some people are surprised at that. I think it's a lot higher. It's not, very little timber is going into landfill nowadays. So based on that, some of these figures are quite low. So you transport, generally your wood processing is fairly close to where the wood is deemed waste. So you've got a certain amount of processing that might be at the transfer station, or maybe even a dedicated wood recycling centre, and that's where C3 is where you start to add back in that carbon emission, either C3 or C4, depending on which disposed of. I've put it in C3 here because the majority of it is going to be going into biomass fuel production, so it's that processing for that. And these sort of figures are based on that mix, so very low emissions at the end of life anyway. The big issue is you have to add that sequestration back in at the end of life. Okay, so that's the key issue there. But just one of the key things that we've put in the paper is which wasn't anywhere to be found. Actually, we couldn't find any information on end of life destinations for certain types of timber. We had the overall figure, like we said, which was very kindly, the Wood Recycling Association put these figures out every year showing that's breakdown of stuff going to biomass energy and everything else, but it didn't break it down into the different types of products. So myself and Jane worked through this from my experience on the waste side and Jane's experience on the carbon side and energy recovery, incineration. We've come up with these numbers here, which are obviously aligned with those 69, 20, 10, 1 figures that we had in the previous slide of where it's going, but try to apportion it where is the timber likely to go from each different area. So, like solid wood timber, if it's hardwood, no preservatives, no coatings, that's much more likely to go into your animal bedding than anywhere else. Whereas something like a treated timber is more than likely going to go into into a biomass energy recovery. As long as it's non-hazardous, it can go into panel boards. And like I say, if you've got timber that's actually coming out of an older building now, which is in a lot of cases now is deemed hazardous, so you floor joists, roof joists, tile battens and things like that would be classed as hazardous unless you can prove otherwise. The only destination for that now is actually that biomass with either incineration with energy recovery or incineration with low energy recovery. So that's why we split those two bits out. So this is the first time this has been done. And actually, if you compare this to what's in the RICS statement, there's a vast difference. The RICS statement is very wrong. So if you're using that, I'd forget about that at the moment and very much concentrate on using these figures. If you're looking at timber buildings, use these figures instead. So that's our end of life. We then talk about our beyond life cycle, and we got, timber's got a really good story as far as the circular economy here. You've got, obviously we're regrowing that resource, but we use it in maybe mass timber. That mass timber may be reclaimed and, might be reused in a smaller building first off. So we can cut down those panels, use them again. So that's reuse. It then might be recycled into a panel board on the second life, a third life of that product might be a panel board that goes into your furniture or your chipboard flooring. So that's then stored in that build for another long amount of time. It might then go into insulation even, and then biomass. So that you might get 4 or 5 uses out of a piece of timber through different stages through what we call a cascading recycling approach. And it's only at the end of that life, which might, could be, 200 or 300 years possibly, before that goes into biomass. So very good product. And like we said, that CO2 from that then goes back into feeding those trees to grow again for a new crop of timber. So very good cycle. But that D cycle, it does get quite complicated, because what it's talking about is what are the benefits of that to other services. So for example, one of the examples that we've got, if you're using waste timber for biomass energy, you're not then using maybe natural gas from the grid. So there's a benefit there in carbon because you're not using gas, you're using biomass. So that is then allowed for within that module D discussion. So, and again, by reusing timber in, recycling it and using it in panel boards, you're not using virgin timber. So there's a benefit there from the, not having the transport emissions maybe associated with the virgin timber, because your source timber is much closer. So there's another benefit there. So that's the sort of benefits that get allowed for in that section. But like I say, they are only a quoted figure. Don't form part of the overall calculation for the embodied structure. So it's a complicated bit, and if you want more information on that, I'd have to pass you on to Jane for that one. So once we've got our products, and we start looking at buildings then, and we say, right, because each one of those, when we look at that, we obviously got as a product, but then we incorporate that into the building level approach as well. So we take our EPD, what can we do to try and minimize the embodied carbon within that structure? And the first thing, the most important one, is, do we actually need a new building in the first place? Could we actually repurpose the existing building on the site? And there's a lot of work and timber can be really good for this as well, because if you've got an existing concrete or steel structure and you want to put some more floor area in it, you might want to be able to add an extra floor or fill in an atrium or something along those lines. You could use timber for that. So you're not actually demolishing the building, you're just extending it in effect, either on the roof or out the side or out the back, whatever it may be. So the first thing to do is, can you repurpose that existing structure? As soon as we knock down that building, even if we put a timber structure back up, there is going to be a carbon cost associated with that. So we've got to try and make sure we reuse whatever's there in the first place. Once you've done that, assess the embodied carbon early to maximize the opportunity to reduction. So make sure that we're looking at all, a full carbon picture, even if we're just using the industry figures for certain products. Make sure we look at those first, and to make sure we can make the best choices for that building on a carbon basis. Optimize the building form and layout, simplify the design. Do we need all the stuff that we put in that building? Do we actually need to put ceilings in? Could we leave it as exposed soffits, etc.? Review the embodied carbon of the different structural solutions or different solutions generally across the building. Compare those whole life carbon of the building servicing options. So obviously then you start to look at the operation of the building, and timber again, if you look at things like passive house and stuff like that, very well suited to passive house construction, keeping that operational emissions very low. Consider the benefits of carbon storage within the building, i.e. that the timber, if you're making it out of timber, there's going to be a carbon storage benefit in there, so we can sell that to the client and say, look, we're keeping that carbon out of the atmosphere, we're storing it in this building for an infinite amount of time as long as this building stays up. Focus on the hotspots, consider resource efficiency and light weighting, use low impact products, recycled materials, durable materials like we said earlier on. Try and incorporate that circular economy so we can keep stuff in use for as long as possible. And obviously try and reduce waste on site. And one of the good things to do that is using modern method of construction, off-site manufacture. If we can bring stuff in that's just bolts together, that's going to reduce that waste on site. And make it simple. That can make sure you can actually get to stuff that might go wrong. So if you've got pipe work that's buried in walls and you get a leak, that's very difficult then to get hold of. Make sure you've got access to get to that stuff. Once we've done all of that, we've got that carbon figure down to as low as possible. It's we're not going to get to zero carbon. Not straight away, not in the next 5-10 years in my mind, maybe not until even 2050. We're going to struggle to get to zero carbon. There's going to be an element of carbon in there for a long while yet. So, but once we've got that down to as low as possible, then we can start considering offsetting to make that building net zero, what we call net zero. So the bit of carbon that's left, we can offset. And when you're talking about net zero, that needs to be through what we call a carbon removal program. So that would be things like afforestation. Planting new forests would be a net zero, rather than say mitigation, which would be say off-site renewables or community projects, clean cook stove somewhere. That's a mitigation thing, and that's not allowed under net zero according to the latest standards that come out from the Science-Based Targets Initiative. It must be afforestation, and when you look at the price of that, that may not be cheap. I think you look at the Greater London Authority, they're actually putting a price of around £95 per tonne on any residual carbon that you need to offset. So it's quite a significant amount. So that's really us. We're ready for questions now, David. But just to leave you with Andrew, with just to leave you a few call to actions. Really, ensure you carry out a whole life carbon assessment of the building to BS 15978, and use that professional statement, RSS professional statement. Use carbon data from the environmental product declarations for the actual product you're using wherever possible. Otherwise, if you can't get hold of the data for the timber product, you can look at the Wood for Good website, and the ICE database will have some carbon figures in there. Include sequestered carbon where the whole life carbon assessment is completed. You can allow for that sequestered carbon. Make sure you include it. But if you don't do a whole life carbon assessment, you can't include that figure in the assessment, but you can state it as a separate stored carbon figure. You can state it as a separate number in your report. So do that. Shows the benefit of having that stored carbon in the building. Incorporate those as circular economy design principles to ensure optimum resource efficiency, long life and end of life reuse. And after all your reduction measures have been exhausted, only then use your carbon removal offsetting schemes such as tree planting for your residual emissions. Thank you very much,
Charlie.
Andrew.
Thank you. If you'd like to stop sharing your screen, I'll ask Abraham if he would to put up the results of the survey. I'm having trouble with my iPhone this morning, so I haven't been able to sort of answer the Slido this morning. But there we go. Let's see what the answers are. See if any surprises, Charlie, and what the what we've got. So, is your organisation committed to achieving net zero? Only 11 people have answered. That's disappointing. Less than half the people on the call. But anyway, there we are. About a third of those on the call have answered this. Let's have a look at the answers, please.
They might all have iPhones, Andrew.
Yeah, they might not. Mine's in Spanish. I think it's a throwback from when I came back from Gran Canaria. I haven't flipped it back. So can I have the answers then, please, Abraham? That would be good. Hopefully it's 100%. Oh, not quite. Okay.
Undecided for you, undecided, but okay.
Yeah.
But that's good to see 82% have got committed to achieving net zero. That's good.
Okay, let's have the next question then, please, and the answers. Current understanding, limited is 60% and good is 40%. So that's interesting. Hopefully you've helped move. Hopefully you've moved some of those up from limited to good and good to very good. Next question then, please, Abraham. Current understanding of the circular economy, slightly less. In fact, some are down at none. Okay, so again, none in the very good column, Charles. So a lot of work still to be done there, I would think.
Yeah, we might need to do that circular economy one we talked about, Andrew.
We did. Yeah, we're thinking, ladies and gents, of having a circular economy session next year. So yeah, that's a tick in that box, Charlie, I think. What's the next one then, please, Abraham? Your experience of working on or specifying structural timber. So good, limited, some are very good. That's interesting. And an equal number that are none. So sort of a middling there, isn't it? Yeah, I think those that are not involved will become increasingly involved. I'm sitting on a panel at the moment, government panel, looking to increase the amount of timber used in construction. So that direction of travel is heading your way.
Absolutely.
What do you believe happens to the majority of timber waste? So recycled 36, landfill 36.
Yeah,
there you go.
Massive numbers. That's not unexpected. That's that landfill. Obviously, most people think a lot of timber goes to landfill, and actually it's 0%, and actually much more is fuel for energy production. So yeah, good. Hopefully,
you said it's about 1%, didn't you? Landfill.
1% landfill. 1% landfill. 69% going to fuel for energy production.
Right. Okay. Are there any more slides, Abraham? I don't think there are there?
That's it. I think that's the 5 questions.
Yeah, that was the final one.
Yep.
So now, because I'm struggling with my phone, I don't know whether we've got any questions. Yes, we've got a couple. So don't forget, folks, if you've got any questions, pop them in the Slido and we'll ask Charlie now. So Rob Lamb, who's a good friend of ours.
Yeah.
Hi, Charlie.
Rob, well, how
sensitive is the whole life carbon assessment to the use of specific manufacturers' data and transport distances, etc., in comparison to using generic values? There we go. That's a good one to start.
Okay, yeah, that's a good one. That sort of ties in with some of the stuff that we've been looking at with Wood for Good. For example, when you look at, I think the CLT one on the Wood for Good, the embodied carbon data, particularly for transport, there makes that quite high. I think it's about sort of 0.4 tons per cubic meter or something like that, where the average, is actually probably down at about 2. So it is really important to make sure that where you can get that manufactured data, a lot of the manufacturers are doing a lot of work to try and reduce those, especially the factory emissions. So the sort of the A3 emissions, they can do something about that, and moving over from, say, gas boilers or gas kilns, sorry, over to biomass kilns really reduces that CO2 emission intensity. So I think, yeah, if you can use the manufacturer's data, use that for your whole life carbon assessment for the buildings. Obviously, there is some work being done to try and pull out all of those EPDs at the moment, and I know that the ICE database done a bit of work on that. I know iStruct are doing something there, and their carbon calculator, the iStruct carbon calculator, is actually using actual EPD figures, an average of a number of EPDs for the new version that's coming out soon. So, worth looking at those. That will use a much more up-to-date data than maybe the ICN would for good data at the moment. But obviously, the key thing is at some point you really want to plug in your actual manufacturer's data, because it can be quite sensitive. And like I say, the transport distances, depending what you're looking at and what type of system you're looking at, there isn't. When we looked at it, there wasn't a lot of difference in the transport emissions of actually getting, say, sawn spruce from Scotland as it was from Sweden. Because, if you've got a job in London, for example, that's the caveat here. Looking at a job in London, transporting sawn softwood from Sweden on a boat over to the UK, or transporting it down from lorry from Scotland, were actually not too, quite similar emissions. It was just a little bit less for the lorry coming down from Scotland as it was shipping over in Sweden. However, obviously, the nearer you are to Scotland, the much lower that emission will be. So on average, it's probably, better to use homegrown product, closer to the site overall. But on certain jobs, there's not a lot of difference. But it is.
Thank you, Charlie.
It's that transport that is quite significant. So that's the challenge that the industry's got over the next few years, is to try and get that transport emissions down.
Okay, thank you, Charlie. Next question then, please, Abraham.
So this up, yep. Rob again. What needs to happen to increase homegrown timber to 20% of area and increase the amount of homegrown structural timber? Okay, couple of good points here. So we need political will. I think that's probably the key one here. There's a lot of stuff being said around planting more trees, but not necessarily a lot of action to make that happen. There's still a lot of processes and hoops that people have to go through to plant those trees. For example, I know there's one in I think it's Northumberland. There's a big planting scheme up there which took 5 years to get through all the planning and requirements before they could put a tree in the ground. That's the sort of bureaucracy that they're having to go through, and I think we need to try and make that process a bit more streamlined, a bit simpler. Not necessarily reduce the requirements, but we do need to make the process a lot simpler. We can get all that stuff together and put all the evidence down a lot quicker than was happening for that particular scheme, for example. So there needs to be some political will to get that to change, to get that to move. As far as then incorporating that into homegrown structural timber, it can be done. Obviously, the conditions for growing trees in the UK are different to, say, Sweden. So generally, the timber that comes out of the UK is a C16 strength quality. Not too much of an issue now for something like walls, where we're having to make those walls a lot thicker to get the insulation in. So it's not necessarily an issue there. It becomes more of an issue maybe in your floor, floor joists and stuff like that, where you want to span a certain distance, and you might need to use a bigger timber if you use a homegrown timber than a Swedish timber. So that does a slight difference there. But as far as things like engineered timber, there is some studies being done were done by Napier University, and I think they're doing a lot of work at the moment. I think BSW done a CLT house and made some CLT panels from homegrown timber for COP26. So there was a house there that was made out of homegrown CLT. So it can be done. The performance that I saw from those studies was very good. The CLT performed, made out C16 timber was performed very well compared with Austrian CLT. There was, almost got to the same strength grades overall because of the lamination. So I think there's a good future for that. I think the key bit is obviously the making the supply chain efficient. At the moment, for example, one of my other hats on, I'm doing some work with a reusable pallet company at the moment, and some of the figures that are coming out of there, we use 18 million single-use pallets in the construction sector each year, which works out about 600,000 cubic meters of homegrown timber going into single-use pallets, which lasts maybe 3 months. So that's not, for me, that's not a good use of the resource. What we need to be doing is making those pallets reusable, which is what, for example, Loop is doing. That could reduce that that resource, that result required for pallets by about 3/4. So that 150 cubic meters would all be going into the pallets, and they would be reused a lot more. That releases 450,000 cubic meters of timber that could go into things like CLT, and that's they use wood that would have been destined for pallets in the study that Napier done. So and just to give you an idea, I think the last figures I saw is around 200, just under 200,000 cubic meters of CLT and glulam were imported into the UK, was the last figures I saw. So we've got potential there to move that to a UK supply, maybe.
Okay, Abraham, as I say, I can't get onto my iPhone. Have we got any more questions? There were only 2 at the start. I don't know if there are any coming. Yes. Okay. Am I right in thinking that the embodied carbon is associated with where the tree is felled? How do we incorporate this into targets for net zero construction?
Is associated with where the tree? Not necessarily, no.
I wonder if that takes into account what you were talking about earlier in terms of transportation.
Yeah, I think that there is obviously an amount of embodied carbon. Yeah, there's So if the tree is felled, a long distance away, there's going to be more carbon associated with that timber. So yeah, so it goes back to really to sort of partly to Rob's question. If we can produce more homegrown resource, that will, in certain cases, reduce that overall carbon intensity, especially as we decarbonise road transport. That is going to happen. We're going to see probably hydrogen lorries at some point, hopefully by 2030. That will help with that. So yes, there is a certain amount of where the tree is felled. It will increase that carbon, carbon footprint. So, for example, if you're getting, any timber product, if you've got plywood coming over from China or plywood coming over from Scandinavia, which one's going to have the higher carbon footprint? I think that's quite easy to tell.
I mean, if I may, Charlie, I'd just like to come in on that second point in terms of how do we incorporate this into targets for net zero. With my Construction Leadership Council hat on, I've been part of the Construct Zero board all this year, and we launched a series of metrics and milestones at COP26 a few weeks ago. I would like to see the whole industry get behind those 9 priorities and 28 metrics. It's not the finished article, but at least it can show that we're working together as a sector with common targets. So that would be my plea. Are there any more questions, please, Abraham? No. Okay, so there are a couple of comments in the chat box, which I'm going to go through, Charles, if I may.
Okay, yeah.
First of all, David Lambert says, can we have a copy of this PowerPoint PDF presentation? Yes, you can, David. If you go to Leaders Meet's website very shortly, they will have recordings not only of this, but of every webinar we've ever done since March last year. So that's answers that. But I've got one here saying, really good presentation. Thank you, Charlie. Andrew, would you be interested to hear more about how timber can be promoted more? I think would be interested, I think is the question, would be more interested to hear more about how timber can be promoted more. We're having real issues in Scotland to use timber in public buildings. That's interesting because in terms of house building, about 90% of all houses are constructed in timber frame. So that's a very strange question for me to hear. But Charlie, I don't know whether you've got a view on that.
I think we're talking about public buildings. Maybe we're talking about more sort of schools and hospitals and stuff like that, which I think there is maybe some inertia there from governments. I haven't heard anything from Scotland. I actually thought they was trying to promote that more in Scotland than maybe England. So it is a surprising one to hear that. So something we'll have to look into.
My hope is I've just been asked to sit on an interdepartmental government working group looking to increase the amount of timber used in construction. So that's DEFRA, BEIS, DLUC and so on. My hope is that we don't get the politics involved, so that anything Westminster does, Scotland goes against it, because I've seen that happen in other agendas.
I don't think it would. If because Scotland, it's got a great resource up there, and I think they just need to be, be confident in using what they've got at the end of the day. I think that's what it's about. I think the key issue is maybe that, when you start looking at those public buildings, you are looking at more engineered timber solutions, which we haven't necessarily got in Scotland or the UK anywhere at the moment. So maybe that's where we need the investment, and that's the bit that needs bringing up.
Right. So I've had a note here to say building control and insurers are not happy to sign off timber frame designs unless all assemblies are tested. A lot of work going on in that arena at the moment.
Goes back to our discussion yesterday, doesn't it, Andrew?
Lots of work happening within the STA and beyond. Timber Accelerator Hub, a massive amount of effort and resources going into that agenda, I can promise you. We're very well aware of that situation. We're trying to remove as many obstacles as possible in the use of more timber in construction, because we know how critical it is in terms of achieving net zero. Look, it's 1:01, so I need to wrap up. First of all, Charlie, can I thank you so much for giving your time and your knowledge, and we will get you back next year to talk about the circular economy. If you want to receive a certificate of attendance for today, please go to mypropass.co.uk, and there's the code on the screen, CWFM hash 0795. So that's your certificate for today. And then next week we have our final webinar of the year. It's around procurement. Delighted that Ruth Griffin is going to join us to take us through the top 10 issues to consider when procuring construction projects. So that's our final webinar for 2021. Can I thank you, Abraham, on behalf of Leaders Meets for the excellent work as always. And may I wish all of you a very, very good afternoon, and have yourselves a great weekend. Hope to see you next Friday. Bye-bye now.
Thanks, Andrew. Thanks, everyone. Thanks for all the good feedback. Cheers. Goodbye.